9.3 absolute value equations and inequalities. This first example is an absolute value equation. So after having read the section, remember an absolute value basically is measuring the distance from zero. So it's always positive. That doesn't mean your answer or your solution will always be positive. We just basically want to find all the values that will end up making this equation true. So the first thing we have to do here is isolate our absolute value bar expression. So in order to isolate this, we need to move the plus 1 over by subtracting 1 both sides. So that will give us the absolute value of y minus 7 equals 3. Now, you always want to make sense of this first. Remember, this is making a statement that the absolute value of some expression is equal to 3. Well, we know that the absolute value always has to be a positive. So make sure you look at this number. There may be problems where after you simplify, this number ends up being a negative, which would end up being no solution because it's impossible. You can't have absolute value equal a negative. So always keep your eyes open. Now, what this is saying is that the distance, whatever this y is, once you subtract from 7, whatever answer you get inside here, the distance from 0 is 3. Well, what two numbers have a distance of 3 from 0? Either -3 or +3. So that's why we set this into two equations. Our first equation will be y minus 7 equals -3, or y minus 7 equals +3. And we go ahead and solve these. This gives us y equals, if we add 7 both sides, 4, or y equals 10. Now remember here we solved an equation, we found a solution, so our final solution should always be in set notation. So go ahead and list them. And order doesn't matter. Now here we're dealing with two absolute value equations, which is fine. Remember, this one can be positive or negative, this one can be positive or negative. So when we open up the absolute value bars, we're really going to do exactly what we did up here. We can leave one of them positive both in each equation, and the other one can be the one that actually gets a negative applied. So our first equation will be n minus 6 equals 2n plus 8. And our second equation will be n minus 6 equals, now we want the negative of this entire equation. So I can just put negative of and just put some parentheses so that we remember to apply this negative to this entire equation by distributing it. So let's go ahead and solve this. So here we can go ahead and subtract the n both sides. So we have -6 equals n plus 8, and we subtract 8 both sides, giving us n equals -14. Here we first need to go ahead and distribute this negative, giving us n minus 6 equals -2n minus 8. We can go ahead and add the 2n to both sides. 3n minus 6 equals -8, and then add 6 both sides. 3n equals -2, divide 3 both sides, n equals -2/3. So our two solutions are -2/3, -14. And like I said, order doesn't matter. Now let's work on some absolute value inequalities. So the first thing we need to do is simplify. Simplify meaning, well, not necessarily simplify, sorry. We want to isolate the absolute value bars. Once we isolate the expression that has the absolute value bars, we want to see which form we have. Remember, in your notes or in the book, if you look, there's 4 different forms, and you want to do a comparison. Okay, so in this case, we need to subtract 2 both sides. Once we subtract 2 both sides, we have the absolute value of x minus 3 is greater than 5. Now, if you look in your notes, this is basically the third form. If you're looking in your book, I can tell you which form that is. It's basically on page 600, it's part C. So we need to open this up into its two equivalent, or basically what inequalities this represents. So the first one will be x minus 3 is greater than 5, or x minus 3, so the left side always stays the same, and we apply the negative to the right side. But remember, if you're going to apply a negative when it comes to an inequality, you have to flip the sign. So this will be less than negative 5. Now we have this inequality that requires us to do a union. So this will be x is greater than 8, or x is less than negative 2. Go ahead and graph this. Here's 0 somewhere, here's negative 2, and here's 8. So I want every number less than negative 2, so that'll be to the left of negative 2 with parentheses, and I want every number greater than 8. So we wanted a union. So the union will be a combination basically of both of these intervals. We can go ahead and write this in interval notation. So that would be parentheses negative infinity to negative 2, parentheses because the negative 2 is not included, union, parentheses again because the 8 is not included, from 8 to infinity. Let's do one more. Okay, so in this one, once again, we need to first go ahead and isolate our absolute value bars. So that would mean this is a plus 9. I need to subtract 9 both sides. So the negative absolute value of x plus 4 is greater than or equal to negative 3 minus 9 would be negative 12. We never ever take anything inside the absolute value bars. So we need to go ahead and undo this negative sign. This set of absolute value bars is being multiplied by a negative, so we can go ahead and divide both sides by a negative 1. Now notice we're dividing both sides of an inequality by a negative, which means our sign will flip. Absolute value of x plus 4 is less than or equal to 12. So which form is this? This is basically the second form that we're shown, but instead of using a less than sign, we have a less than or equal to sign. So this one we will write out as a compound inequality, and we can write it all as 1. So this one will be now negative 12 is less than or equal to x plus 4 is less than or equal to 12. You'll know this is the correct form as long as all arrows, if you look at these as arrows for a moment, are pointing to the left, and the left limit is smaller than the right limit. So it should work the way the number line works. Okay, so let's go ahead and solve this. We need to isolate the x by subtracting 4, so we need to subtract 4 in all three parts. So negative 12 minus 4 is negative 16. It's less than or equal to x, which is less than or equal to 12 minus 4 is 8. We can go ahead and graph this. Here's 0, negative 16, 8. I want every number that is greater than or equal to negative 16 and less than or equal to 8. So both endpoints are included, and shade everything in between. So if we write this in interval notation, it will be brackets, negative 16, comma, 8.